again, right at the very beginning of the document, what I want to point to you is like, reading and trying to understand what you read. So we went through the first example, and that first example, we talked about how to use an application called Grapher to do it. And, we talked about this example over here. What do we do? We said what the solution was. We said it was on an interval. And then what we did, we checked it. I hope you remember me doing this. You may have watched those videos, you may not have watched those videos, but the bottom line is we did that example over there. I also went through how to learn to do this on a computer, all right? And what I do, I basically talked about these graphs over here. That's all I did, all right? So then hopefully as you're moving along, you're starting to realize that you're trying to learn by moving along, and that's going to take effort, by the way. So we get to this example over here. There will be a video shared with you about me doing the direction field, which is over here. I'll go through the video of that. And then over here, there's going to be a bunch of curves that go through that direction field. And they'll look like circles to me, right? And again, if you watch the video, I talk about scale and things like that, so you're not too deceived. But what I want to do is start talking about, if you were asked to, look at this thing and come up with the direction field on your own, I would say, for the most part, especially on a multiple choice exam, is look around for easy things to do. So for example, let me just talk about this a little bit. Not that I want to, do every line there. And that's going to be minus x over y prime. One thing I would recommend, I'm sorry, not y prime. I made a mistake there. So it's minus x over y. What are we doing? We're talking about this over here. Let me go back to the direction field. A lot of times in multiple exam, they give you a differential equation, and they ask you which one's the slope field. Well, looking at this over here, I want to point out, if I were looking at it, one thing I do know is when the y becomes 0, so when the y goes towards the 0, this is going to have an undefined tangent line. So it's going to be vertical. And I'll be honest with you, I'm observing that almost immediately, right? So what I mean by that, when y is 0, that's this thing over here, I'm seeing vertical tangent lines. I mean, I'm not everywhere drawn, but I'm seeing them. Now, someone says I see other things over here, but it's so true that I'm seeing these vertical tangent line where y is equal to 0, all right? Now, granted, someone's going to say, what's happening over here? There's some artifacts, but let me just start to move up. And what I want to do, I want to move into the first quadrant. Well, let me erase this over here. As I move into the first quadrant, both x and y are positive. So the slopes are all going to be negative. Now, how do I know that? In the first quadrant, both x and y are positive, but the coefficient over here is negative. So I know that everything in that first quadrant's got to be negative. What am I looking at? All the slopes in the first quadrant, I'm seeing those things, they appear to be negative. Now, before I say that, I also want to point out when x goes towards 0, I'm expecting to see horizontal tangent lines. Now, granted, there are artifacts here. What I mean by that, you have to know where these things are being drawn from. These are being drawn from the line, the y-axis, by the way. And I'm seeing all those lines there being horizontal. And I'd expect that, by the way. Now, if you went to the second quadrant, what are you looking at over there? All the slopes are positive. And why is that? Well, x would be negative, y would be negative, x would be positive there. You got a negative coefficient on it. And again, you look around, you see that, right? Next thing up, if it's properly scaled, you should look at the direction field and draw curves through it. All right, you should be able to do that. All right, let me get my eraser out, and eraser has been over here. And I'm pretty convinced that the curves that go through that direction field are in fact circles. So what I want to do is I want to write down what the equation of a circle looks like. And let me write this over here. X squared plus y squared is equal to r squared. And if you differentiate that, which I want to do, that's going to be 2x. And then what do you get over there? Dx dx, that's 1, plus 2y dy dx. I'm going to say it's y prime. And derivative of r squared is a constant, which is 0. So if you were to do that, what do you get? You get 2y, y prime, equals minus 2x. Divide both sides by 2y. This should be reminiscent of what you did in Calc 1, implicit differentiation, by the way. So what do you get up there? Minus x over y. So that does appear to be the case, by the way, that this is a recognized solution that's over here is going to be a circle. Now, granted, make sure you understand what we're doing over here. We're graphing it. How do we graph it? We're using technology to do that. Furthermore, we should look at the graph and understand how it relates to the actual differential equation. Next up, what kind of curves go through that? Right? What curves go through that would be curves that look like circles. Then we draw representative circles, we get that over there. As we go through this over here, they might give you an initial condition. They may not give you an initial condition, but if they do, you gotta be careful of that. Let me just write that one down for you. So over here, they're giving me a condition that needs to be met. Let's write this down. So we know the solution to this thing is going to be x squared plus y squared is equal to r squared. All right? What do they tell me? They tell me y at minus 1, right? Y is a function of x would equal 0. Now someone says, what does this thing say to me? It says there's a point. What's point going to be? Y would be 0 when x is minus 1. Let's plug this in here and try to figure out what r is. What do you get there? Well, x squared would give you 1, plus y squared would give you 0. So I know r squared is equal to 1. So we get a solution over here. Let me write that down for you. The solution will be x squared plus y squared is equal to 1. That's a particular solution. Again, our general solution, these are written down for you. The particular solution is this one over here. It meets that initial condition. And this over here is a more general solution. X squared plus y squared equals r squared. Thank you.